Hello everyone, I'm Mohammad Khan from Saginaw Valley State University. Today I'm going to talk about selection of inter-chip interconnect materials for electronic chips, or how we can select material for interconnect. Here is a brief overview of topics I'm going to talk about today. So what you see here on the right side is a superconnect or interchip interconnect, which is known as coil packaging. And as you can see, metal line there, those are connecting line between chips, and they are known as nodule. And simulation model is actually shown on the left, where copper is encapsulated by silicon dioxide, which is an insulating material, and at the end you can see tin that could be solder, and that actually join two chips. And the reliability of that interconnection is based on the properties of these solder or tin. So we're going to focus on that part. And this superconnect is mentioned in ITRS, as you can see. So the bottom simulation model is, the bottom is a chip carrier, middle part is an epoxy, and the top is substrate or dies, and that is connected by nodule, and that those nodules are connecting two chips. And as you can see left and right here, this is a physical nodule connected by solder. And if these substrates are of different semiconductor, they are known as heterogeneous. If they are of same semiconductor, they are known as homogeneous metachips. I'm going to show result for homogeneous metachip. So here are the material parameters of solder, which can join those nodules. So elasticity, Poisson ratio, and thermal coefficient or expansion coefficient. As you can see in this table, tin copper, that is actually relatively weaker compared to others. So we're going to compare tin lead, tin silver, and tin copper solders. And to predict reliable life cycle or reliability life cycle, we use a Coffin-Manson relationship, as you can see on the screen. And the parameters are theta and alpha, which are fatigue ductility constant and fatigue ductility exponent. As you can see, for these three different solder, both theta and alpha is actually smaller for tin silver compared to others. Okay. And here I'm going to show simulation result. The first one for tin lead, and the simulation is done for reference 0 and minus 55. I'm going to show minus 55. So with respect to minus 55, if temperature is 125, the number of cycle or life cycle would be around 1000 for this solder. For tin copper, it is around 500 cycle for the same temperature range and same structure. And for tin silver, that is around 8000 cycle, which is actually improved reliability. So if you go back to those table and compare, you can see tin silver has a smaller value of both theta and alpha. And if you look at the equation and rearrange the equation in this format, and you can see NF is a strong function of alpha, but weaker function of theta because of the long term. So failure cycle is a strong function of fatigue ductility exponent, and that is observed for this interchip interconnect. So this can possibly be applicable for other solder joints in circuits. And numerical value, as you can see, can be an indicator of improved cycle. So it might help select a solder for some specific application in electronics. So here are references for this work. I'd like to thank Professor Gary Bernstein at Notre Dame and EC department at Saginaw Valley State University. Thank you.